Welcome to part 2 of how to model a pivot joint in FreeCAD. In part 1 I modeled the base of the pivot joint, and if you haven't seen that video I'll link to it in the description below. In this video I want to focus on modeling the arms of the pivot joint, and I'll do that in 3 steps. The first step will be to create kind of the rectangular portion here, and then the second step will be to create the curved part, and then the third step will be to create the hole through the center. I won't be modeling the bearing here. I'll just model the hole so you can put a bolt through it. So with that said, let's get to it. So the blueprint doesn't tell us a whole lot about these arms. It doesn't tell us how thick they are. It doesn't tell us how much clearance there is between the end of the arm and the base. It doesn't tell us the diameter of this thing, so of this curved section. So we'll have to make some guesses on that and infer some values. For the thickness, I'll probably make them just as thick as I can and still be able to get a bolt through this. For the clearance, I'll choose maybe 1 millimeter, and then the diameter of this curve looks to be the same as the length of one of the sides of this interface, so I'll use that. So with that, we'll fire up FreeCAD and start modeling all of that. Alright, so let's start modeling the arms. I'm going to need some values in the spreadsheet, so a lot of these are just guesstimates. Let's do the arm thickness. I'm going to make that 4 millimeters. Alright, let's do we'll call it the arm clearance. And just like 1 millimeter. That's the space between the arm and the base. Alright, so we have those 2 pieces. Now I'm going to create a datum plane based off of this. So let's do a datum plane off of this plane face. And then let's create a sketch on that datum plane. And I think what I'll do is I'll model the one that's on this edge and then copy it and then position it. I think that approach will work. So I'm going to start just with a rectangle here. Let's get that first piece going there. And let's make that symmetric about the x-axis. Now I'm doing these 2 points instead of these 2 points because I'm going to put a fillet on these corners, and those 2 points are going to disappear. So I don't want to have to redo that. So let's make that symmetric and get rid of the redundant vertical constraint. And then we'll just do the fillets now. Do a fillet on that corner and that corner. And then let's set the width of this thing here. So that's the arm thickness. Yeah, 4 seems reasonable. And then let's set the height of this thing. And that's the base interface width. Alright, it's looking good there. So we're going to want it kind of like this, and we're going to want the radius of the fillets set properly too. So I guess I'll do that now. Let's just set this one first. And I'll just use the same fillet radius as what I used for the base. Okay, and then let's set this one and this one equal to each other. And we have 1 degree of freedom left, and that's obviously this like position. So I'm going to set the horizontal distance constraint between the origin and the edge here, and it's half the distance of the inner base face. So we can just put that in here. Base interface width divided by 2. All right, and we're fully constrained. So now let's just copy this. And let's just place it over here. Okay. So we want this also to be symmetric about the axis. So we'll put that there. And then the distance from here to this edge, I want it to be the thickness of the arm. But I don't want to reference this edge directly, because if I end up changing the base, there's the topological naming problem, and I don't want to run into that. So this distance here is really the half of the base interface width minus the thickness. So that's the distance from here to here. So that's what I'm going to set. So spreadsheet base interface width divided by 2 minus spreadsheet arm thickness. And there we go. So our sketch is fully constrained. Let's close this, and then let's rotate it so we can see the padding, and then I'll pad it. That's the right direction, and that looks pretty good. So the length, now the length is going to be the clearance plus half of the diameter of the curved part, right? Because you can imagine once we get the curved part on here, the curved part's going to be, if it were a complete circle, this face would go halfway through it. So it's really half of the diameter of the curved part, which is really half the distance of this from here to here, which is the interface, the base interface width. That may not make sense, but I'm just gonna do it, and you'll see what it turns out like. So let's do spreadsheet, and then that is the arm clearance plus spreadsheet base interface width divided by 2. Okay, so let's reposition this, and let's hide the datum plane. All right, so far so good. Let's rename these things. So this is the arm. We'll call it the arm. I don't know if it's lower or upper. I'm going to call it the arm. We'll call it the upper datum plane. Make a slight adjustment to that. And this is the arm upper and the arm upper sketch. I mean, I could just call this the arm datum plane. And call this arm, and call this the arm sketch. And save. All right, so the next thing I need to do is create the curved part of this thing. So let's create another datum plane. Actually, yeah, we'll create another datum plane on the plane face. And let's take a look at creating a sketch here on that datum plane. I'm going to change this to orthographic view. It's just a little easier to work with. So basically I'm going to draw the same thing, but I only want half of it. And then I'll rotate it around the x-axis. So basically the same sort of thing. And let's fillet those. Not that one though. And then let's zoom in a little bit so I can click that. And then let's set the radius constraint. Base fillet radius. And then same thing on this position here. And that's the base interface width divided by 2. Okay, and then the height. That's also the base interface width divided by 2. And the width here is the arm thickness. All right, fully constrained. Now let's duplicate that. And we'll just put it right here. All right, so the only thing we need to set here, I think, yeah, we need to set the vertical and horizontal position. So let's put this point on this line, and let's put the distance between here and here. Go ahead and select the spreadsheet, and that was the base interface width divided by 2 minus the arm thickness. Nope, that didn't work. Let's delete that and redo it. I think what I wanted, I probably wanted this and this. Try that one more time. Okay, now we're constrained. So let's go and close that, and then we're going to revolve that. We want it around the x-axis. And we only want it 180 degrees. Now, why is that going more than that? Why is that going more than that? This is not what I expected, so interesting. There we go, horizontal sketch axis. That's what we wanted. Okay, I think what's going on here is when I did the base x-axis, it's doing on the origins, relative to the origins base x-axis, which is not what I want. So we'll go back to there. Click OK and reorient this so it looks reasonable, and turn off that. All right, that looks pretty good. Let's compare that to that. They do seem a little tall to me. I'll have to figure that one out. I may come back and make adjustments here. All right, so let's just rename these things. Here I'll call it the arm end datum plane, and the arm end sketch, and the arm end. And save. All right, so let's put the hole in here. So create a datum plane on the plane face, create a sketch on the datum plane. Now the hole is on the y-axis. So we got that, and we know the radius. We want it to be the same as the hole that goes through the base. So actually I think we have that defined as a diameter. So we'll constrain the diameter. So that is the base hole diameter. We could create a separate entry in the spreadsheet for this, but for now we're just going to use the same value. And the last thing I need to deal with is the position of this thing. So we need to set this constraint like that, and that is, we're going to do the same thing. It's going to be the arm clearance plus the base interface width divided by 2. And then let's close that and let's pocket that. And for this, I'm going to go through, I could go through all, but I'm going to just set this to be the base interface width, because that's kind of the widest piece we have on here. Okay, and then let's hide that datum plane. And let's rename that arm hole datum plane. Arm hole sketch in the arm hole. And save it. Alright, so that does not look as good as this. It seems too tall to me. That might just be a visual thing. But I'm going to pause the video, do a little bit of investigation, and just make sure that that's really what it's supposed to be. And then I'll come back to it. Alright, so I'm convinced that's right. Now, kind of the last piece we need to look at here is this dimension f defines the length of the entire assembly from the tip of one tab to the tip of the other tab. And we've sort of made a guess on the thickness of the base. So I think we need to resolve that. So the overall length here is 49 millimeters. So I'm going to put that in first. I'm going to call that, let's call it the assembly length. And we know that's 49 millimeters. All right, so what we want to do is calculate the thickness based on everything else we know. So we know halfway between this assembly length, half of the assembly length is right through this, right through the center of the hole. And we know right through the center of the hole is the clearance between here plus half of the diameter of the circular curved part, the arm ends we're calling it. And then we also know that there's a tab height. So basically, if we take half of f and then we subtract off the tab height and we subtract off the clearance and we subtract off the radius of the curved part, that should be the thickness of this base. So I'm going to put that in here. Base thickness, we had it set just at 5, but I'm going to reference other values in the spreadsheet. So it's going to be equal to the assembly length divided by 2, and then subtract off the tab height, and then subtract off the clearance, that's the arm clearance, and then subtract off the base interface width divided by 2. And that comes out to 7.5 millimeters. So let's save it and see if everything turned out okay. Alright, so let's look and compare that to this guy. And I think that looks pretty good. That looks a lot more like that. It still looks a little bit on the thick side, but I think that's right. Let's just pivot it here, look at it from different angles. Yeah, let's go with that. Alright, so that's it for this part. I'm going to wrap this video up. If you liked it, hit the like button, subscribe, press the bell button if you want notifications. And I'll do a third part, and in this part I will put this together in an assembly to kind of make it look like this. So we'll see you in the next one.